We are in geometry. Today's date is 3/1.
I don't have the notes. I thought these were them, but I guess not. I don't know what this is.
Does anyone else have
Take the
notes?
ripped one, I don't care.
No, we should have notes.
No, if you tape it for me, I'll make
Oh, here it is. Almost. All right. So everyone has the notes now. All right. We are on lesson 8-2, today's arc length. You'll notice that yesterday's title, or I should say Monday's title, all the way back on 8-1, where is, I guess Tuesday's title was 8-1, that was arc measure. Today is arc length. So instead of finding the degrees of an arc, so again, an arc is just talking about some part of the circle, some edge of that outer circle. Instead of saying how many degrees is this, we're going to say how long is that in inches, in feet, or like some length now. So, bit of a review. Circumference. What is circumference? Quiet raised hand. What is circumference? Only 3 people know what circumference is. Uh-oh. 4 or 5 people. Can you hand those out for us? Colby, what is circumference? Yeah, it's the length of that outer circle. Or we can say, instead of outer circle, you can say the length of the edge of the circle. I think that would be even better. Length of the edge. If you want outer circle, write down outer circle. What is the radius? Quiet raised hand. What is the radius? Easy. What is this, like kindergarten review, something like that? Yeah, Chewy. A straight line from the center, so like that. That intersects where? That intersects the edge of the circle, the circumference of the circle? Yes, exactly. So it's a straight line, so let me come here. You can sketch a straight line, you don't need to have a ruler, but it's a straight line that comes from the center of the circle. So that is going to be called my radius. R is the radius, that is the length from center to edge. So it's not the full diameter. Diameter is the full length. Radius is only half of the length. We only have part of the length. And then so far, arc length, we've defined it up here. Usually we call arc length S. I don't know who called it S, but a lot of the times mathematicians call arc length S. So this arc length up here, we're going to call it S, and it's part of the circumference. All right. So, quiet raised hand. What is the formula for circumference? Circumference is equal to what? And remember, if you have your card, you're raising your hand with the card held in it. Go for it, Martine. Good guess. Not quite 360 degrees. It should have pi in there somewhere. You want to give it another shot, or are you going to give it to someone else? All right, you get to choose then. There it is, 2 pi r. Write it down. 2 pi r. This is something you will need to memorize. 2 pi r. I multiply the radius by 2, which is really the diameter, and then I multiply by pi. All right, and then here is your new formula that you're going to be using all of today, and it's the way to figure out what the arc length is. So if you have some central angle, so I'm going to call the central angle here theta. So if I have some central angle theta, that's going to be divided by the total degrees in a circle. Everyone shout that out. The total degrees in a circle is 360. So this represents the percent of the circle. If it's 60 degrees, it's 60 degrees over 360, which is 1/6. You have 1/6 of the circle if it's 60 degrees. This is just some fraction or some ratio or some percent of the circle. This percent of the circle is equal to your arc length divided by the total circumference. So let's write that down. Arc length. And usually we call that the letter S. Arc length divided by the total circumference. And I'll call that C. So I could boil down this formula and just say it's S over C, but it's more useful to actually see what S and C are. That's why I wrote the whole word. All right, that's the whole lesson in terms of what the formula is. Let's see how to apply the formula. I'll leave the formula up there. All right, so example 1. We know that we have a circumference of 12. So we know that C, this bottom right-hand side, is going to be 12. We also have a central angle of 300 degrees. Notice that I'm talking about this bottom part of the circle, this major arc length, not the minor arc length up here. What is the length of this major arc length over here? I'm trying to figure that out. Who can help me set up this problem? Quiet raised hand using this formula. Use this formula to solve the problem. What are we going to do? India, go for it. So just making sure everyone is following right now. The theta that we're looking at is 300 degrees. So we're doing 300 over 360. Continue on. Thank you, India. The 12 represents this whole length, the whole circumference.
So then it's going to be
S over 12. Yep, and you can choose whatever variable you want. Normally we use S. You could use X. You could use any letter, but I like S because it does match up with the arc length that we have up here in the top right. All right, thank you, India. I'll take your card. Oh, perfect. So from now, I need to solve for S. What am I going to do? Quiet raised hand. I need to solve this ratio. Question, yes.
Which one is the circumference and what is the arc length?
So circumference in this problem,
Yeah.
circumference is 12. This 12 refers to the whole circumference. So if I were to unroll this circle, this line would be 12 long. And then the arc length, where'd that go? I can't even see. It's so dark in here. The arc length would just be from here to here. So it's a very big arc length. It's a major arc. All right. Still a question? No? Okay. How am I going to solve this ratio? I have a ratio on the left, ratio on the right. Whenever I have two ratios with an equal sign, I'm going to do what, Anna? Cross multiply. Do that for us. And make sure that everyone S's in your notes look like S's and not 5s. Be careful. 360S is equal to? Oh, not 360 times 12.
300 times 12.
There it is, 300 times 12. And that's going to be, yep, 3,600. Thank you. Thank you, Anna. You can turn in your card. It's a little bit off. All right, what am I going to do now? To both sides, quiet raised hand. You can raise your hand even if you don't have a card, but I need to see the card raised if you want to answer, and I'll give you preference. What am I going to do to solve for S? S is our variable. You have your card? No. Beverly. Divide both sides by 360 to isolate my variable, and then 3,600 divided by 360. You can do this in your head. So the 3 cancels out, the 6 cancels out, the 0 cancels out, and I'm left with, there it is, yep. Say again? 10. If this whole length of the circumference was 12, then this part of the length on that bottom is 10. That makes sense. It's just slightly smaller than 12. I'll scroll down so that people can see the work. Ask me questions. This is one of our 2 examples that we're doing today. Oh, thanks. No questions. We're moving on to a slightly harder example, example number 2. This one you will need a calculator, so you can use your laptops, you can use your phones. All right. We know that we have a radius of 3. This length is 3. And it has an arc length of 6.28. So this minor arc, this small arc, is 6.28 long. I want to know the measure of that central angle that corresponds to that minor arc. What is this angle? All right, I'm going to have to use the same formula over and over again. Same formula. Someone help me set it up. What's the formula? You want to give it a shot, Chewy? No? You want to go for it, Brian? All right. Good so far? Yep. Uh, 6.28, yep. Over, and this is the hard part. Let's see if you can get it. Good guess. It wasn't 3. It's the circumference. So look at the formula for circumference. Circumference is equal to 2 pi times what, Brian? What's r?
3.
There it is. 2 pi times 3. Yeah, very well. Thank you. I'll take your card. Yeah, that was hard to set up. And there it is. We set it up. We said we don't know theta, so leave it theta. We know it's always going to be 360 on the bottom left. Top right is going to be our minor arc length, 6.28. And then the bottom right, that's the hardest part. That's circumference. That's where we use that formula all the way at the top. 2 pi r, 2 pi times the radius, which is 3. All right, we have everything set up. Now we need to solve. This is where you pull out your calculators and get ready to solve after we set this up, after we solve for theta. In order to solve for theta, what do I need to do to both sides? You can cross multiply, but I'm not going to cross multiply because that's just going to add another step. What do I need to do to both sides of this inequality to get rid of 360? Right now I'm dividing by 360. What's the inverse operation of 360? Who can do this for us? Lorea, go for it. There it is. Multiply by 360 on both sides. Multiply by 360 on both sides. That cancels out. We need to enter all of this in our calculators. All right, give it your best shot. Know that you're going to be rounding to the nearest whole degree. The nearest whole degree, that means round to the nearest integer, the nearest whole number. So everyone should be doing this on our calculator now. I should be seeing everyone either with a friend or by themselves using their calculator to find the answer. So if it's going to be in the bottom, you want parentheses on the bottom. So if you come back here, you don't have to redo everything. You just do second delete. You're really inserting now, and then do a parenthesis. And then you can go to the far right and enter a parenthesis at the very end. Now it'll work.
What's that symbol thing again?
Pi?
Oh, is that what that is?
Yeah.
What is that?
6.28 and then divided by pi, 2 pi, 3. Do I press equal?
Try it. Something messed up. You might need parentheses on the bottom. So do 6.28 divided by 6.28 divided by. Now start your parentheses, so top left, and then 2 times pi times 3.
2 times pi.
3. And your okay, now multiply that by, yeah, perfect. Nearest whole number. All right. Raise your hand if you have an answer. I see 1, 2, 3, 4 people have an answer. Raise your hand with a card if you have your card. Oh, perfect. Yeah, Sam. 120 degrees. So let me use a different color here. 120 degrees, like that. Give me a thumbs up or a thumbs down, whether or not you got this or did not get this. I'm getting a bunch of thumbs up. Thank you, Sam. And that's it. Those are our 2 examples. I'll show you how to do this on your calculator. By the way, I've noticed that some people are still using their phones, and that's totally okay because you'll always have your phone as a tool because they're always in our pockets. But if you want to go to desmos.com/scientific, then you get this calculator, which I use on a daily basis, and you can type in everything that I had right here. Let me do it. 6.28. I'm now going to divide by. And on the bottom I have 2. Oh, I have 2. I have pi. I just typed in pi, and it automatically turns into pi. Or I could also go to my functions button, and there would be pi in the bottom right. So I did 6.28 divided by 2 pi, and now I'm going to multiply that by 360 times 360. Oop, that's 350. 360, and there's my answer. I can hit enter, or I can hit.
You forgot the 3.
Shoot, okay. Come back here, 360, and also times 3. Yes?
Are the pictures accurate? Because if that equals 120 degrees, I think we have the opposite.
No, I think this picture is accurate. So think about 90 degrees. 90 degrees would be about right there. And then we add another 30 degrees and you get 120. Yeah, but it's always good to check the picture, to check the intuition. I'm glad that you did that. Thank you, Larry. Oh yeah, so what was the calculator called? Great question. So if you go to desmos.com/scientific, or you just Google scientific calculator, it's usually one of the first things that comes up. I want you to use this on tests and quizzes. I will let you take this or use this calculator on quizzes and tests. I want you to know how to use this. It is a very valuable tool. I'm pretty sure there's an app for a Desmos calculator as well if you want to use it on your phones. All right, that's all we have for today. Are there any questions before we move on to the summary and homework? Oh, we don't have well, I think you guys were saving your homework pass for another day. So we do have homework tonight, and it's really easy. It's just using that formula over and over again.